So we've got a question here. We've got a car towing a trailer. The car weighs 1200 kilos, so it's got a mass of 1200 kilos, and the trailer has a mass of 400 kilos with its load. Now it's being towed by a light inextensible rope. That's a good condition that we need to be able to calculate our result in this manner we're doing in this question. And the driving force on the car is 900 newtons. So that's the power that the engine is producing. Now the car has a constant air resistance of 150 newtons, and the trailer, that should be has constant air resistance of 350 newtons. So we want to find the acceleration. Obviously this is moving from stationary, so calculate the acceleration, calculate the tension in the rope, calculate the speed after it's travelled 100 metres, and how long does it take to travel that 100 metres. So to answer this question, first of all, we need to draw a forces diagram. So let's just draw our road here, and we can have the trailer here, and it's got 400 kilo mass, so that's 400k, towed by a rope to a car which has mass 1200. Okay, now the other forces we need is the driving force of the car is 900 newtons. So that's pulling the car forward. So the 900 newtons is going in this direction. Now the rope, as the rope is being pulled from the car towards the trailer, the tension is in this way. And from the trailer towards the car, the tension is going in this direction. So these two are what we call the tension. So let's put TN for tension. This represents the trailer. This represents the car. Now there's an air resistance of 150 newtons acting on the car. So that's going in this direction. So we want another force here, which I'm going to write, let's just write it underneath. That's 150 newtons. And the trailer has an air resistance as well of 350 newtons. So that's also acting in this direction. So if I put that one there, that takes care of all of that. And that's all of my forces represented. Now the one thing we need now, as we've got acceleration, as this is accelerating in this direction, we need to put just a marker here to let us know where our acceleration is, and that's going in this direction. Okay, now let's calculate the acceleration and the tension in the rope. So first of all, let's look at the car. So for the car, we've got forces in this direction and this direction. So we've got 900 going in this direction. So we've got 900, and then this way we'll put for minus, because we've got the acceleration this direction. So we've got the tension and the 150. So minus the tension and the 150. Now, if we use Newton's law of motion, force equals mass times acceleration. So that's the key rule when answering these questions. Force equals mass times acceleration. So there's one force, and now we need mass times acceleration. So the mass is 1200, and acceleration we need to find. So that's part of here. So the tension and the acceleration is what we need to find. Now let's have a look at the trailer. So for the trailer, the forces of that, using force equals mass times acceleration. So the forces on the trailer is the tension, and that's going in this direction, same as the acceleration, so that's positive. And the resistance on it is 350 newtons, so we need to subtract that because that's going in the other direction. And then we need mass times acceleration, which is 400 times A. So that's for the trailer. Now here we've got a classic situation, two variables and two equations. So simultaneous equation, if we eliminate one, then we can find the other. So as we've got Tn is just worth one, coefficient of 1 for each, we just add these together. And on this side, that looks like 1600A, that's straightforward. Then we've got 900 minus 150 is 750. Minus 350, that gives me 400. So therefore we can clearly see Acceleration is 400 divided by 1600, which gives me 1/4 or 0.25. So acceleration equals 0.25 meters per second squared. So that's my acceleration. Now, as I've got this, I can now plug that into one of these equations and solve for the tension. So let's use this one here. So tension minus 350 equals 400 times 0.25. So I just put 1/4. So then we've got Tn equals 350 plus 100. So therefore the tension in the rope is going to be 450 newtons. So that solves part 1 and part 2. Okay, so that's all good. Now we've got our acceleration force. We can use that in our next 2 parts of our question. Calculate the speed after 100 meters and how long did it take to travel. Now these, as we need to find speed, we've got distance and we've got acceleration. So these are SUVAT equations. So let's write down our SUVAT variables that we know. Time we don't know, we need to find that. Acceleration we know, that's 1/4. Velocity, we don't know the velocity, we need the speed as it's going on, that's part of what we need. So that's going to be needed, obviously this time is going to be needed. And the initial velocity is 0, so we can put that one in. And it travels 100 meters. So the displacement is 100 meters, or just 100. Okay, now first one, calculate the speed. So the SUVAT equation for that we can use is v squared equals u squared plus 2as. As v squared is what we find, we know what u is, a is, and the displacement. So we can plug our values into that. So v squared equals u squared, well that's just 0, plus 2 times the acceleration, which is 1/4, and the displacement is 100. Okay, so v squared equals 2 times 1/4, so that's a half. Half times 100 just gives me 50. So v squared equals 50, so therefore v equals square root of 50. Obviously we need the positive version if you take it a square root. So square root of 50 is 5√2. And that's meters per second. Now that's the exact value of the velocity at 100 meters. So you put that in a calculator and it'll give you an exact result. It's going to be just over 7. Okay, so now how long does it take to travel 100 meters? So now we've got the velocity, I can put that in there. Now which SUVAT equation do we need when we're looking for time? Well, the one that springs to mind is S equals UT plus a half AT squared. So we've got the S, we've got the U, we need the time, so that's pretty straightforward. So the distance is 100, or displacement's 100. Initial velocity is 0, so I've got 0t, plus a half times the acceleration, which is 1/4, and t squared. Okay, so now we need to solve for t. So now let's just simplify this off. 100 equals 0 plus half times 1/4 is 1/8, and t squared. So now multiply both sides by 8. So I've got t squared equals 800. T equals square root of 800. And square root of 800, if I do that in surds, well I know 400 will go into 800, which is 20. Square root of 400 is 20. So I've got 20√2. And that's in seconds. Now you can plug that into your calculator, you'll get something around about 20 times 1.4, which is about 28 seconds. So it's going to take 28 seconds, just over, to do the first 100 meters. And when it gets to the 100 meters, it's going to be doing just over 7 meters per second. Okay, and that's our answer.